Okay, thank you for joining us today. My name is Maciej Jadach. I'm working in Grand Parade since November 2017. I work in Sports Channel, which is responsible for bookmaker platform. Today in my presentation I want to tell you more about I want to tell you more about the visual regression itself and the BrowserStack tool and how to improve those tests. So let's start it from beginning. It is quick agenda. We will just quick overview about the visual regression testing, then about the BrowserStack tools, quick demo of using it combined together, and then some of the company use cases. Okay, so at the beginning I will explain in short words what the visual regression testing is. There's a lot of tools, automation tools of how the software behaves, but sometimes we need the automation to check how the software looks. So this is where the visual regression came in. In simple words, the visual regression perform user interface screenshot comparison. You capture the screenshot and then compare it to the baseline, and on the output you have the third image with differences. It's like on the graph. So with the first run of the VR tests, we'll call VR tests for shortcut the visual regressions. So there is no reference screenshot, so the test will pass and the current screenshot will be marked as the reference one. And if the framework will find the reference screenshot, it will make the image comparison of it, and it depends on the options you choose, the test will fail or will pass. So okay, let's go to another one. Yeah, so visual regression tools provide, as I mentioned before, the image comparison, which is the output of our tests. So underneath there is a lot of image processing libraries such as reassemble.js, images magic, or Python image library. And yeah, take a look at our example. We have two versions of footer, and the question is, how fast will you spot the difference between these two versions? Or ask yourself how many assertions you would need to cover all the elements on this footer to make it is rendered properly. So as I said before, the third image, the difference between one and the second image give us on the output the third image called div image, and it looks like it's with is in magenta color. We have highlighted the changes from the current compared to the baseline. We have the PayPal icon missing, the 18+ icon missing, the last paragraph is missing. So we can spot the difference in the whole layout and the composition on the right sides, as well as the typos in about the William Hill information on the left sides. And we have one dynamic element, the clock. Remember that, we will get back to it later on. Yeah, so there's the list of most popular frameworks available for visual regression testing. There is Random, there is Ref, Backstop.js, Galen, Gemini, Phantom CSS, and there is also the WDO Visual Regression Service. It's the WebDriver IO plugin. Of course, there is the web services providing the same functionality like Screener.io or Percy.io. The last one is bolded because this framework we will use in our presentation. Okay, so this is the technology stack we will work on in this presentation. On the top of that there is the WebDriver IO. This is WebDriver binding for the Node.js, for the JavaScript. Personally, I really like it. It has a lot of extensions, a lot of plugins, synchronous command handling. It is very handy if you switch from the Java to JavaScript and don't understand the asynchronous properly. So yeah, that's good. And as we speak about the extensions and the integration, I've listed two of them which we will use. The visual regression service is a plugin which takes the responsibility for taking screenshot and comparison of images, and the BrowserStack service, it's a kind of proxy which connect our test runner to the BrowserStack servers. Okay, so let's get a quick of pros of visual and challenges with visual regression testing. As we have in our example at the beginning in the footer, the single test can cover multiple checks on the page or on the UI elements, like checking for labels, font types, images, icons, and everything that shows on the UI as the UI components. We can compare the UI components in different browsers, for example, by using BrowserStacks. It gives us the more value to the functional tests. That's why we choose WebDriver.io. It's the binding for WebDriver.js. So for the functional tests, we can easily adapt it to the visual regression. We can check how the software looks, as we mentioned before, and in overall it improves product quality and user experience. So let's go to the challenges. The important thing is that the screenshot-based visual regression testing can only work when the UI components are predictable. When we have the mutable UI components, we need to exclude them from testing. Like the clock in our footer example, there was dynamic elements which shows the current date every time you turn the page on. The less painful challenge, but still, is maintaining the reference screenshots. Usually we'll keep this reference screenshot in your code base or even in the different repository, but still, this is the only part which you need to do manually for exchanging the baseline screenshot if the changes are intended. There is a web service called Spectre which could take care of it. Well, I hope you can note it down and check in home. Yeah, so sometimes or even often we need to exclude some elements from our visual regression tests, or some workarounds for special cases like ignore comparison. We can omit the anti-aliasing in the different anti-aliasing or colors. We can have the mismatch tolerance, which is the percentages of difference which will be accepted by the tests to fail or not. And the most common one is just to omit some elements. In most cases, it's just applying the CSS rules to them. One is hide, which is hide by applying the visibility hidden or opacity 0, or remove to just give us the display none. We need to remember to run the visual regression tests in the same isolated environments, because browsers will render each element differently on each display. So we need to use some kind of X-virtual frame buffer or use built-in browser's headless mode. So that's the anti-aliasing, that's the ignore comparison anti-aliasing for, because sometimes on different screens we have different fonts or something like that. Okay, so what's beneath that WDO visual regression service? We have two options for choosing the image processing library here. By default, this is the reassemble.js. To be strictly, it's some kind of modification called node reassemble.js. It's the image processing library written in the JavaScript. And the second one is Graphics Magic, as the owners of application call this as Swiss Army knife for image processing. It's native program, so as you can guess, if you want the performance, we should choose these second options. This is simply configuration for that. We only need to make it only need to add the program to the system path, and the visual regression service will take care of it. So I think it's a nice place to prepare the Dockerization for our tests. Okay, for those who don't know what is the BrowserStack, it's a cloud-based cross-browser testing tool which allowed us to test web application on different browsers and different operating systems and every combination of it. It also allowed us to testing browsers on real mobile devices as well. You can choose Android, iOS, Windows, even Windows Phone. We have two options to testing it. We have the manually, you can test it manually, or we can automate the process using the remote WebDriver. So it's just Selenium thing. So there is a libraries provided for every languages which is being used in testing. Okay, this is how it looks like, the main product of BrowserStack. I mentioned before, the live, it's purely for the manually testing. We just open the browsers in the certain device or operating system. There's a lot of options. The BrowserStack adverse side themselves, as they have 1,000 to hundreds combination or something like that. I've never checked that. We need to believe them. This is the automate. This is what will interest us the most. This is just the quick overview about our build. Our build will be our test run. So we have the overlook of the created session of the created browser session with operating system and browsers and versions. In the details view, we can get to the more details. We have some nice debugging features like recording the video or some network lags or text lags from the remote WebDriver command executions. Sometimes it slows down the execution, so we can turn it off easily. For example, the video, we don't need it always, so yeah, that's fine. Okay, so using BrowserStack without being able to run tests locally would be quite useless, because thinking about the pre-production environments or something run locally on your machine, you can get access from the BrowserStack servers to your inner network. The problem is solved by something called local testing, which is described by the BrowserStack. It's just a simple proxy server which will resolve all the network traffic through this server. For the manual testing this live product, you only need to Chrome extension. For any other browsers or automation, you need to turn on the BrowserStack local server by your own. You need to download the binary from the BrowserStack website and configure it properly. They have a pretty nice guides for every languages or every testing framework. So yeah, and as we speak before about the integration of WebDriver IO and why I like it, there is the WDO BrowserStack service which takes care of. We took the whole configuration from us to connect our test runner to the BrowserStack servers when we need to provide API key. Okay, so how it works in the short ones, it's a kind of proxy server. As I told you, we just send the Selenium desired capabilities to BrowserStack session where the browser sessions are created, and we have traffic from on the both sides. The browsers on the BrowserStack have access to our inner network, so we can test locally run application. Okay, let's go to the example. This is how our test case looks like. It's a simple one created only for the demo purpose. It's the WebDriver IO, it's the Mocha test framework. I think the code is self-explanatory even for those who don't know JavaScript. So we have standard before hook with opening the base URL provided in the config file, and we have function check element with CSS selector for footer. We will get back to this function later on. Yeah, this is the execution of how it looks like when we start it up. The BrowserStack local server is turned on, the WebDriver IO is connected to them, and the sessions are being created in the BrowserStack. We can see it on the website of BrowserStack in Automate tab. As you can see, there is a 4 session created for 4 real mobile devices. We have the access to the logs on the live. Yeah, sometimes it's a bit laggy, but that's fine. And in the text logs, we will get the remote WebDriver command execution. So as you can see, there is screenshots, several screenshots took, because the visual regression service is packing them into one, because the size of viewport is smaller than the element. Okay, so we've all got almost our execution done. And yeah, we have 4 tests passed. So this is this is expected, because as we mentioned before on the first graph, the first run of visual regression, when there is no baseline screenshots, or reference one, the same name, the test will pass, and the current screenshots will be marked as the reference. So as you can see in the code base, we've got now the new directory with the screenshots, which will be used as the reference in the next runs. So yeah, we can go to the next run. Yeah, the flow is the same, starting up the BrowserStack local server, sending the desired capabilities to BrowserStack, creating new sessions, and the execution of the code. Yeah, it took some time. Okay, the flow is just the same. Sometimes we need to wait for BrowserStack, but the possibility of using the real mobile devices is worth it. As we can see, the execution is the remote WebDriver commands are executed. There is another screenshots took, and we have test fail. Why we have test fail? Because again we have the dynamic element on the footer. This is the clock. It's the same situation like with the first footer on our first example. We have failed tests. In the code base, the WDO visual regression service will create the different screenshots showing us the difference. This example for one of mobile devices. If we zoom in or zoom out, zoom in, we can see that the magenta color highlighted the difference. So yeah, that's the case. That's the problem we need to get rid of. So as we speak before, we can hide elements to make our tests pass, to hide these dynamic elements, because we need to exclude them to make the visual regression works properly. So yeah, let's go back to our test case and to our check element function. From the WDO visual regression API docs, we can read that the browser.check element function, beside the selector parameters, it took the object parameter where under the key height we can provide the array of CSS selectors of elements which we will hide by applying the CSS rule opacity 0 to them. Yeah, later there is assertions for every value in array report. Why this is array? Because in the basic usage of WDO visual regression service, we have parameter which change the viewport size when making this browser.check element function. This works pretty cool for the responsive designs, but it's useless in our case because we are using BrowserStack and our footer is made in the adaptive way. So yeah, we only need to check our test case to change, to provide this array of selectors we want to hide. There is the hide selectors variable where we put the CSS selector for this clock, and we just change the check element function in our test case. So yeah, in the end we receive something like that. As we can see, the clock is hidden now, and there is the worst part, because we need to do manually changing the reference screenshot, because the first one is being saved as the reference one and will be used always until there is the certain file name consisted of test name and browsers and etc. So yeah, this is the worst part. We need to exchange the images. So yeah, well, our first case in company where we wanted to apply the visual regression was the refactoring CSS bundles. That was tasks consisted of refactoring whole CSS in our monolith and changing the responsive design for the adaptive one. We opt to keep the one-to-one, this new and all the new layout one-to-one, but it was not possible. And we need to, from the testing perspective, we need to answer some questions. So how we check if styles are not broken, or how we automate the whole process, or at least some part of it. and how to achieve device and browser coverage. So yeah, we started for gathering the URL lists of our sportsbook product with the most used components and sites by customers like football and etc. In parallel, we get the statistics for the device coverage from our customers, and we implement the visual regression tests and automate the process in continuous integration. In our cases, that was Jenkins. Yeah, the flow of testing was as on the slide. We just grab the URL list. We have our feature under the feature flag, so that was very good approach for the visual regression testing. So first we go to the web page without widget toggle, took the reference screenshots. Then we go to the URL, the same URL with the feature toggles on, take another screenshot and compare them and generate the results. Okay, we end up with something like this. Yeah, I know everyone wants to hold 100% green tests, but in that case it was impossible. Don't bother it. The trend is also growing because we will adding the URL to the URL lists. This is combined results from different stages of developing the new layout. We have a lot of changes from UI teams. There is a lot of phase because of that, because those changes were intended, and the main reason why there is a lot of failed tests is, as I mentioned on the beginning, we need for visual regression tests, we need the isolate environment. We can't isolate. UI need to be static. There shouldn't be any dynamic elements or something like that. And unfortunately, we didn't have this luxury to mock all the data and just to on the end receive the static page with the same amount and the same kind of information. So yeah, there is a lot of fails, but at least it gives us some feedback to which parts we need to focus on and manually check it. Yeah, so I think that's a big plus. So yeah, we've implemented the custom allure reporter for our visual regression changes. We want better visibility in our test reports. So we want to every failed test attach the reference screenshots, the current screenshots, and the difference one. In our example, you can see that we have the visual regression catch ups the problem with the different gap between those icons in the carousel. This is a simple example, and yeah, that custom allure reporter help us a lot. As you can see, there is a lot of numbers and huge kilobytes size of those images, and in terms of resources, those tests were heavy. When we speak about the storage, it was heavy, and we speak about the performance, it was heavy because we were comparing the whole web pages. So we took that advantages that WDO Visual Regression Service could use this graphic magic instead of reassemble JS image processing library. That was a good shot because we've achieved like 40% improvement in the test execution time. So yeah, another simple one. It's just in our company we have a lot of microservices, and we want to test our services as early as we can. So we have the idea that we check the functionality from the functionality and non-functionality perspective, the microservices, before we get to release them in the pipeline. So we have a lot of projects which has these jobs in GitLab CI pipelines, which just checked if the microservices are rendered properly for each devices. Okay, so I think that's it. Any questions?